Hello everyone, myself Shrishti Srivastav, and today I am going to explain the topic successive differentiation. Now, what is successive differentiation? If y be any function of x, then its derivative dy by dx will be a function of x whose differentiation can be done. Hence, we can find again differential coefficient of dy by dx. The derivative of dy by dx, that is d by dx of dy by dx, is called the second order derivative of y and is represented as d2y upon dx square. The successive derivatives of y with respect to x is called successive differentiation and are denoted by dy by dx, d2y upon dx square, d cube y upon dx cube, and so on. Now, in simple terms, we can say the process of differentiation of the same function again and again is called successive differentiation. Now, for example, let us consider a function y equals to fx. Now, if we differentiate it, we would get dy by dx, which would be equal to f dash x. Now, if we differentiate it again, then we would get d2y upon dx square, which would be equal to f double dash x, and so on. Now, if we want to find the nth derivative, then that would be equal to d to the power ny upon dx to the power n, and it would be equal to f to the power nx. Now, let us move to the various notations. So, the first derivative of y with respect to x is dy by dx or y dash or y1, which is represented as f dash x or d fx or simply dy. Now, the second derivative of y with respect to x is d2y upon dx square, which equals to y double dash or y2, which is equal to f double dash x or d square fx or simply d square y, and so on. So, the nth derivative of y with respect to x is d to the power ny upon dx to the power n equals y to the power n or yn or f to the power nx or d to the power n fx or simply d to the power ny. Now, let us find out the nth derivatives of some standard functions. Now, let us consider a function y which equals ax plus b whole to the power m, where m is a real number. So, y1 would be equal to m into ax plus b whole to the power m minus 1 into a. Now, if we differentiate it again, we would get y2 equals m into m minus 1 into ax plus b whole to the power m minus 2 into a square. Again, if we differentiate it, we would get y3, which equals m into m minus 1 into m minus 2 into ax plus b whole to the power m minus 3 into a cube, and so on. Now, yn would be equal to m into m minus 1 into m minus 2 up to m minus n plus 1 into ax plus b whole to the power m minus n into a to the power n. Now, if we see another example, y equals 1 upon ax plus b, which can be written as ax plus b whole to the power minus 1. Now, if we differentiate it, we would get y1 equals minus 1 into ax plus b whole to the power minus 2 into a. Again differentiating, we would get y2 equals minus 1 into minus 2 into ax plus b whole to the power minus 3 into a square. Now, if we differentiate it again, we would get y3, which equals minus 1 into minus 2 into minus 3 into ax plus b whole to the power minus 4 into a cube, and so on. So, yn equals minus 1 into minus 2 into minus 3 and so on up to minus n into ax plus b whole to the power minus n plus 1 into a to the power n. So, the formula comes out to be yn equals minus 1 to the power n into n factorial into a to the power n whole upon ax plus b whole to the power n plus 1. Now, let us prove d to the power n into e to the power ax equals a to the power n into e to the power ax. So, on differentiating, we get d into e to the power ax equals a into e to the power ax. On differentiating again, we would get d square into e to the power ax equals a square into e to the power ax. Now, if we differentiate it again, we would get d cube into e to the power ax equals a cube into e to the power ax, and so on. Now d to the power n into e to the power ax equals a to the power n into e to the power ax. Let us move to some examples. Example 1. Find the nth derivative of y equals x to the power n. Now, differentiating with respect to x, we get y1 equals nx to the power n minus 1 using the formula d by dx of x to the power n equals n into x to the power n minus 1. Again, differentiating with respect to x, we get y2 equals n into n minus 1 into x to the power n minus 2. If we differentiate it again, we would get y3 equals n into n minus 1 into n minus 2 into x to the power n minus 3, and y4 equals n into n minus 1 into n minus 2 into n minus 3 into x to the power n minus 4, and so on. So, we get yn as n into n minus 1 into n minus 2 into n minus 3 up to 3 into 2 into 1 into x to the power n minus n. So, n minus n becomes 0. So, we get x to the power 0, which equals to 1. So, yn equals n into n minus 1 into n minus 2 into n minus 3 up to 3 into 2 into 1, which is equal to factorial of n. So, we get yn as n factorial. Now, let us see another example. Example 2. Find the nth derivative of y equals e to the power mx. To find the solution, we differentiate it with respect to x. So, we get y1 equals to m into e to the power mx. Again, differentiating with respect to x, we get y2 equals m square into e to the power mx, and y3 as m cube into e to the power mx, and so on. Now we get yn as m to the power n into e to the power mx, which is the required solution. Now let us move to example 3. It says find the nth derivative of y equals log ax plus b. Now if we differentiate it, we get y1 as a upon ax plus b, which can also be written as a into ax plus b whole to the power minus 1. Again, differentiating with respect to x, we get y2 as a into minus 1 into ax plus b whole to the power minus 2 into a, which can be written as minus a square whole upon ax plus b whole square, and y3 equals minus 1 into minus 2 into a cube whole upon ax plus b whole cube, and so on. So we get yn as minus 1 into minus 2 into minus 3 up to minus n minus 1 into a to the power n whole upon ax plus b whole to the power n. Now it can also be written as yn equals minus 1 whole to the power n minus 1 into 1 into 2 into 3 up to n minus 1 into a to the power n whole upon ax plus b to the power n. Now we get the solution as yn equals minus 1 to the power n minus 1 into n minus 1 factorial into a to the power n whole upon ax plus b to the power n. Now let us look at some important forms. So here are the functions and here are the nth derivatives. So if we have the function as x to the power n, its nth derivative would be equal to n factorial. Now if we have e to the power mx, it would be equal to m to the power n into e to the power mx. Now if we have the function as 1 upon ax plus b, it would be equal to minus 1 to the power n into n factorial into a to the power n whole upon ax plus b to the power n plus 1. Now if we have the function as log ax plus b, its nth derivative would be equal to minus 1 whole to the power n plus 1 into n plus 1 factorial into a to the power n whole upon ax plus b to the power n. Now if we have sin ax plus b, it would be equal to a to the power n into sin ax plus b plus n pi by 2. And if we have cos ax plus b, it would be equal to a to the power n cos ax plus b plus n pi by 2. Thank you so much.